All right, in this lesson, you're going to solve absolute value and quadratic inequalities. So the work is similar to a regular equation, but there's just a little bit of a change here where we have to be careful with our inequality symbols. So in inequality, instead of having a single solution, we have an infinite number of solutions. And as a quick reminder, if you have greater than, less than, if you were to graph, we would use a dashed line. It does not include the function. If you have greater than or equal to, less than or equal to, that would be a solid line, and it would include the function. And then our solutions, we're going to write in interval notation. So square bracket inclusive, rounded bracket exclusive. And then in some of these, you're going to be using the union symbol that we talked about on the first day. So we'll start with absolute value inequalities. We're going to solve them like we did equations. The only thing you have to remember, because we're going to do the two cases, you need to change the sign on the second case. Because essentially what you're doing, and I'm going to show you the first step, but then you can skip it once you know what you're doing. Essentially, if I broke this up, x minus 3 is greater than 4, I could start off with this, negative x minus 3 is greater than 4. But you can skip that step if you can remember, because I know in my previous lesson we just negated the right-hand side. You can still do that, but you have to switch the sign. So in this case, you would write it as x minus 3 is less than negative 4. And there's your two cases. And then you would solve. You have x is greater than 7. Here you have x is less than negative 1. So if I were to write this out, I have two inequalities here. I'm going from negative infinity up to negative 1, but don't include it. And then I go from 7 to infinity. And that's my solution. If you wanted to check this graphically, or if you were solving it graphically, you would subtract the 4, and you would have the y on that side, I guess is what you would say. So instead of, normally what we would do if this were an equation, we would subtract the 4 and there would be a 0 on that side. Instead it would be y, let me get my pen, y is less than the absolute value of x minus 3 minus 4. All I did was subtract. I subtracted the 4 to the other side, so the y would have been on this side here. And then you can graph it and see what it looks like. So I'm going to show you how you can easily show the graph by just directly typing in the function. You can use the y, and this is in Desmos again, is less than the absolute value of x minus 3. And then I exit out of the absolute value sign for a minus 4. And there you have it. So you can see that the line's dotted for you, and it crosses the x-axis at 7 and negative 1. And then you can see we go from negative infinity to negative 1, 7 to infinity. So when we're solving this inequality, we're only focused on what is on the x-axis. Okay, so that's where I'm looking at, and that's where my solution is. Okay, so we'll do another example here. I have x plus 2, the absolute value is greater than or equal to negative 5. So I can write the first one just without the absolute value sign. My second case, I'm going to change the inequality sign and change the sign of the value. So x plus 2 is less than or equal to positive 5. So solving here, x is greater than or equal to negative 7. X is less than or equal to 3. Here I have an intersection, so I go from negative 7 up to 3. and that's my answer. Quadratic inequalities are a little bit more complicated, so I'm going to list out some of the steps here. The first thing you're going to do is take your equation or your inequality and place it in standard form, so you have everything on one side, a 0 on the other side. And then once you have it in standard form, you should be able to factor your expression. I'm not going to give you any of them that are the quadratic formula or whatever for this, because we're really trying to figure out the inequality part and not the factoring part. Then you're going to solve it like it's a regular equation, only you're going to take those roots and they're going to be the transition points for intervals that we're going to set up. And then finally we're going to use test points in those intervals to check for positivity or negativity. That's because we're dealing with the product of two numbers. So A, B, if I know that is either greater than, let's say for an example, if it's greater than 0 or greater than or equal to, that determines what kind of signs you can have. So that tells me that this product has to be positive, which means my two values have to be plus plus or minus minus. If I have this, that means the product has to be negative, so I've got to have plus minus minus plus. That's what we're testing for when we solve these quadratic inequalities. Okay, so I'll walk through this example. I have x squared minus 5x plus 6 is less than or equal to 0. We're going to solve that like it were a regular equation to get my two roots that will set up my intervals. So I'm going to factor less than or equal to 0, an x and an x. That's going to be a 3 and a 2, both negative. So I end up with x, a transition point at x is 3 and x is 2. So those are the transition points. Okay. So I'm going to do a number line here. And I have a 2 and I have a 3. I need my product to be negative. So I'm looking for the answers that are going to give me a negative value, I guess, is what I'm going to say. So I'm going to use test points, and let's see here. I'm going to do, let's see, 0 is an easy one here. I'll do 2.5, and I'll do 4. So what you're going to do is you're going to substitute in your test point to each factor, and I don't really need the value. I just need to know whether that factor is going to be positive or negative. So if I substitute the 0 in up here, I get negative 3, so that value is negative. And if I substitute the 0 in here, I'm going to get negative 2, so that value is also negative. So that gives me a negative and a negative. Negative times negative, my overall product is going to be positive. Not what I want. So we go to the second interval. 2.5 minus 3, that's negative. 2.5 minus 2, that's positive. That's going to give me a negative product. That is what I want. But we'll check the last one just to make sure. 4 minus 3 is positive. 4 minus 2 is positive. That gives me a positive. So what this tells me, since I want my product to be less than or equal to 0, my interval is going to be between 2 and 3 inclusive, because it could also be equal to 0. So my answer is 2, 3, that interval. Okay, now we'll do x times 2x plus 7. Your brain might want you to distribute, but don't do that. This is already in factored form for us, so we actually saved a step here. I know that x is going to be, that's a transition point. X is equal to 0, 2x plus 7. So 2x is equal to negative 7. X is equal to negative 7 halves. Okay, which is negative 3.5. So now I want my values greater than 0, so the product has to be positive when you're done. I'll set up my number line. I've got negative 3.5 and 0. I'm going to pick some test points here, -1, -4, and then I'm just looking for positivity or negativity, I guess, between these things. Okay, so -4, the first one is going to be negative. -4 times 2 is -8 plus 7, that's a negative, so that overall answer is positive. For -1, the first factor is negative. The second one is -2 plus 7, that's positive, so the overall product's negative. For the next one, 1 is positive, and 2x plus 7 is positive, so that's positive. I'm looking for my positive answers this time, so now I have the outside intervals. So what that looks like, and it's going to be inclusive because it's greater than or equal to. So we're going to do -infinity up to -3.5 with the square bracket, union, square, 0, infinity. Okay, so here I typed it in just like I saw the original into Desmos. X times 2x plus 7 is greater than or equal to 0, so you get these boring lines, but you can see your solution is shaded correctly. Now, instead of, if I didn't use a 0, let's see if it'll let me do this, or it might just reboot. If I put a y in instead, you still get the same answer, you just see the pretty, the parabola instead. So it doesn't matter which one you do. You're looking at the values on the x-axis here, so it's the same. Y is up to -3.5, and then from 0 beyond. So that is a quick rundown of solving absolute value and quadratic inequalities.